So at the close of our class on 18 January, Wednesday, we mentioned that we would review the proper components of an IP address. And when you see an IP address on the screen, and sometimes you see it just by typing a command in, that address by itself provides initial information, but then the subnet mask is used to calculate where the network number starts and where the host address starts. An analogy that we used on Wednesday was the network identity or number is like a zip code for the US Postal Service. And the rest of the IP address, in this case, the 4, that's the network address for the client, my laptop. So my network address for this client is actually 0.0.0.4. And I want you to notice my words. It's considered good form to use the term dot instead of period. You kind of know who a novice is when you're talking with tech support and they go, my address is 192 period 168. I'm kind of channeling Medea here. It's a Friday. It's a lighter moment. In any case, depending on the range established for the network, there's a trade-off. If the network is smaller, there are fewer clients that can participate. If the network is larger, there are more clients that can participate. And that dynamic is set exclusively by the subnet mask. Now, we like to put things in human terms we understand. And we're going to take a deep dive into this quite a bit in the next modules. So for now, I want you to understand that 255 is the decimal equivalent of a byte. A byte is 8 bits. So in data terms, ones and zeros are bits, either on or off. Bit is a term that's actually a contraction from the proper term binary digit. So if you take binary digit, a 1 or a 0, and you just make it simpler to articulate and express verbally, you say, okay, I'm tired of saying binary digits all the time. So I'll just say bits, right? That's kind of how the term bits came about. And 8 bits make a byte. And half of a byte is actually called a nibble. It's hilarious. We'll get into more of that when we get into the hexadecimal. But for now, 255 represents the maximum value possible for 8 bits or a single byte. A proper network address is 32 bits long. So when you see each of these numbers, they're the decimal equivalent or the decimal numbers we know and use every day, right? This is the base 10 number system, 0 through 9. And when we go over 10, then we have to carry another place. And we go over 90, we have to carry another place. Now we have 100 and so on, right? This is what we'd use every day. We don't even think about it. In the binary world, 255 represents 8 ones. Each bit is turned on, all 8 of them. So when you see 255.255.255.0, what you're seeing are 24 ones in sequence. That's what the computer is doing. And then you see 8 zeros. And I want you to think of a mask as a concept kind of like the masks we wear. There are different kinds of masks. Has anyone ever seen a goalie mask and a party mask?
Yeah.
Okay, so if you go to a cotillion and you're wearing a fancy costume ball mask, most of that mask is open, meaning O for open, O for 0, holes, right? So when you think of zeros, think holes in the mask, right? We'll talk about this more again, and we'll go over this a few times because it takes a little while to get your head around it. But the simple truth is that the solid part of the mask, all the ones, it's kind of like a fence or a brick wall. And all the zeros are like holes in the wall. And the more holes you have, the more clients can be in the network. Let's say that again. The more holes you have, the more clients can be on that network. Now, in this traditional Class C network, and we'll talk about what that means in a bit. This is for a local private network, and Class C is good for households, small businesses, hotel lobbies, that kind of thing, where you can support up to 253 connected clients. When you get to a place like UVI, you will notice that the address range that UVI uses, the public address range, it's a 16-bit subnet mask, and there's 16 zeros that follow. So the entire network addresses available to the University of the Virgin Islands is designated by a subnet mask that has 16 ones and 16 zeros. And that means that UVI can potentially support up to 65,533 connected devices. Now, we'll explain how you break all that out. The important thing is that once you truly understand, okay, this is the zip code, and this is the neighborhood, and this is how big the neighborhood is, and here are the street addresses, then you can start to communicate. So in simple terms, it's like zip code and street address for each house or each building in the neighborhood, okay? And in this case, only the last 8 bits define the number assigned to each client, or the street address assigned to each client. Because each of these numbers represents 8 ones and zeros, they are often referred to as an octet. Has anyone ever heard the term like octagon?
Yeah.
Yeah. So a stop sign is an octagon. How many sides does an octagon have?
8.
8. It's not a trick
Side.
question. Thank you. Yeah, it's not a trick question. So an octet has 8 ones or zeros, 8 ones or zeros, 8 ones or zeros, 8 ones or zeros. When you take 8 plus 8, that's 16. 8 plus 8, that's another 16. That's 32 bits. That's the size of the network range. When you define the size of the neighborhood, then you can easily determine, okay, when it talks to the internet, what's called the gateway address. So each local network has a gateway that allows traffic, the network traffic, to go out to another network. So a gateway is a network device that routes, and I'm using that term intentionally. Sometimes a gateway is called a router. How many of you have Wi-Fi routers? Yeah, you've heard the term?
Yeah.
Yeah.
That's your gateway to the internet, isn't it?
Yep.
Yeah, it's your gateway to the internet. So the gateway to the internet has a local internal address, and it's usually one more than the identity of the network. The identity of the network being the zip code, okay? So it would be great if each of you right now, if you were sitting on your laptop or your PC or a computing system, if you opened up your network properties and looked at the address that you have, and then look at the subnet mask assigned, because those 2 pieces are required to have a proper network address. Once those 2 pieces are on hand, then you can determine, okay, here's where we would normally put the gateway. We would just, so the network identity with this subnet mask would include these 3 numbers. 192.168.1, and then what do we do with the rest of it? Well, it's considered good practice to park a 0 there. So you'd say, okay, the zip code or network identity for this network is 192.168.1.0. Now, what you're going to discover soon is that these numbers are very common in each home network because the network is private and it's internal to your own home physically. It doesn't mix with my network here in my condo, okay? In my home office, you might have a 192.168.1.4 also, but it's not a duplicate address on the same network. My network is different than your network, and they're separated by a lot of other stuff in between, okay? So I know that's, I'm articulating a whole lot more about those specifics because I'm hoping you might replay the recording here. But I want you to understand, IP addresses tend to be leased. That means they're used for a given time, and then when the device is gone or not active, that IP address is reused. Let me say that again. IP addresses tend to be reassigned, and they're reassigned automatically after the device stops being active on a network. Now, why is that an important idea? Let's take our calculator again. How many bits are there in an IP version 4? Now, when you see IPv4, this IPv4 address, everybody see the V4? That means version 4. The current standard of network addresses that we commonly use is called version 4 of the IP protocol. Actually, it's a protocol suite. It's an entire collection of different protocols, and it's called an IP protocol suite or stack. We talked about that Wednesday. You're going to find out that the world is trying to move to version 6. And those numbers are done in hexadecimal, and we're going to talk about that at a different time. We don't want to freak anybody out. Because right now, it's important to get how this works with plain numbers before we get into the version 6. But here's what happened just a few years ago, and this was just 5 years ago. If I take my calculator, can everybody see my screen now?
Yeah.
I'm going to use the y to the x function. So I'm going to put the number 2 in there because that's the base for the binary number system. And there are 32 bits in a network, a proper network range, 32 bits. So when the internet started, they came up with 32 bits to number every connected device in the world. I'm going to hit x to the y because I want to put 32 as an exponent right here. So I'm going to do this, x to the y, and I'm going to enter 32, and then I'm going to say equals. The total number of possible public network addresses since the internet began, like 25, 30 years ago, is 4,294,967,296. I got a question for everyone in the classroom now. Are there enough addresses to go around for every person in the world?
No.
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 No, there's like 7 billion people in the world.
That's right. There's 7 billion. And do you think most of those people only have one network device?
No.
No. So there's another big problem. 5 years ago, the world ran out. 5 years ago, we ran out. And internet service providers basically borrow and recycle addresses constantly to keep people connected. If you've ever wondered why you're like, oh, the internet's there. No, the internet's gone. Oh, the internet's working. No, the internet's not, right? Some of that dynamic that's playing out is the scarcity of public network resources. And it comes down to a simple address. If you don't have a proper address, you're not connecting to anybody. Okay? So what are we saying? The people who started the internet, they're called the International Engineering Task Force, or IETF. They found out that one of the ways we can stretch this is if people set up private internal local networks and they borrow just a couple of specific numbers out of this entire range. So the range of possible numbers for public addresses includes like 254.250, it's a huge range, but essentially you can't ever go more than 255. If you ever see a number that's higher than 255, that's an improper network address, because each number within those dotted boundaries can only have 8 bits, and the maximum number of the highest number you can go is all ones. Now, here's another thing I want to demonstrate to you. I'm going to take my calculator in Windows and I'm going to change it to a programmer calculator. And I want you to see for yourself. We're going to spend a good bit of time and I'm going to show you the ropes when it comes to binary. And then after that, once you get binary solid, then we'll talk about hex. And hex is real easy to understand if the binary is good. But one thing you got to remember is that computers only understand on and off. That's it. That's all they know. And what we're doing is creating a series of values with combinations of ones and zeros that represent characters. So ultimately, every character that we see is nothing but a specific combination of ones and zeros. If I click, now right now you see everybody see the little blue mark right here?
Yeah.
That means my programmer calculator is in decimal mode. So my decimal number system, base 10, 0 to 9, and then you carry over to 10 and 100 and 1,000. The stuff we do every day with currency, we have 10 fingers and toes. That's how it's set by default. I want to click binary, and notice what happened to all the rest of the numbers here. They just disappeared, because the only two possible values you can have in the binary number system is 1 and 0. And if I start to enter numbers and put 8 numbers in a row, and then I look at what's showing up here, I get a value of 255. And what that is, literally, every time you go to the left, the value of numbers double. Now, for those of you that are in computer architecture, you may remember some things about ones and zeros and doubling and all that, right? But a 1 represents that the ones place is turned on. A 1 here represents that the twos place is turned on. The 1 here represents that the fours place is turned on. The 8 place is turned on, the 16 place is turned on, the 32 place is turned on, the 64 column is turned on. And if you read more in the study guide, when we take our deep dive into network addresses, we're going to explain this more. But basically, if this were a decimal number, you'd have a ones place, a tens place, a hundreds place, a thousands place, a 10,000s place, a 100,000s place, and so on. We all know this. I mean, we just understand it that way. But computers only work with ones and zeros. They don't have the rest of the numbers in the world to work with. So for them, this is the ones place, the 2, 4, 8, 16. What do you notice about the pattern there? What's happening each time I move to the left?
It's being doubled.
It's doubled. That's right. So when I turn on each of these, I'm adding those values all together. In decimal terms, if I have 255, I have 5 ones, 5 tens, and 2 100s. okay? And we understand that. We know that there's 200s, 5 10s, and 5 1s. That's what we know because we learned it since we were babies. Computers understand that I take one, if each one of these is turned, whichever one is turned on, I have to add. So I have a 1 plus a 2 plus a 4 plus an 8 plus a 16, a 32, a 64, and a 128. And when I add all of those together, I get 255. We'll review other aspects of this another time. What I want to do, though, is push ahead in our study guide. I just want to make sure that we spend some quality time talking more around about this stuff, okay? So what we're seeing on this screen is a number system that as humans, we understand. But what's really going on in here is 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 0 0 0 0 0 0, right? And that provides a cutoff point where we understand, okay, this is the zip code for the neighborhood, and this is how much you have left for clients, 1 per customer. I only have 1 octet to use for customers, so I can only have 253 customers. Why? I have to use 1 to identify the network. I have to use another to identify the gateway. And then I have a final special address that has to be reserved in every network. It's called the broadcast address. Since all network devices, whether they are wired or wireless, every one of them broadcasts. They put their 1s and 0s out there on the network, and everybody on the network can see them. And so you have to have a broadcast address when you want to make announcements to broadcast to everyone. That's why it's called the broadcast address. If you send something to the broadcast address, everybody's going to get it. I'm going to repeat that again, and then I'm going to beg you not to think like a hacker, because some hackers do this. Once again, a broadcast address is the very end of the range. It is 192.168.1.255. We're going to learn soon when we get into the next modules how important that is, but that special address is just like the gateway address. The gateway address gets your data out to the internet, through the gateway to the internet. The broadcast address sends your data to everybody on that network. So if you send some digital content to that broadcast address, everybody on that network gets a copy of it. It's how communications are coordinated and set up between people, okay? Any questions before we continue on with more in our study guide? You know what? I'm going to flip this. I'm going to do something a little different today. I want 2 of you to ask me questions at this time. Please, based on what you have just received for information, can someone please share at least 2 questions about this stuff with me?
Okay, so I just did the command line thing for
Yes.
like the IPv4, and my own says that I have a preferred one. What does that mean?
Okay, it says preferred.
Yeah,
Would you be willing to share your command line?
sure.
I
Oh,
can-
I
I can stop sharing and then you can click the share button in Zoom. I mean, if you don't want to, you don't have to.
no, I don't mind. You just have to stop sharing yours.
Okay. So I stopped sharing. If you click the green share screen at the bottom and then just click the share again, there we go. Ah, yes. Okay. So you're working a Wi-Fi connection on the campus. And this is, yeah, so when you're in a company setting or an organization, the network specifics look a little different. And what you're finding out here, when you see the word preferred, the campus network management system is assigning you that address specifically. So that's a function of the way the Wi-Fi assigns addresses to each device when they connect. And it's probably part of the DHCP service and the security. You don't always see the word preferred, but preferred tends to mean, okay, this is your special. It's a way of telling a device, okay, this is your specific network address. Meaning it's more official, maybe. That has more to do with the vendor and the brand of networking that is being used. But I'm gonna go ahead and research that a little further because that's a great question. And I want to make sure I'm not steering anybody wrong. So usually when you see the word preferred, though, it is a formally managed network environment, meaning there's a network administrator and there's a lot of security and admin equipment involved on the network, as opposed to just consumer wireless where, you know, in my house, it doesn't tell anybody they're preferred. Also, when you receive an address, you can release or renew the address. So sometimes when you're connected for a long period of time, when an address is renewed, the term preferred may have to do with DHCP renewal. So once again, I'll research that and I'll answer that. That's a great question. Thank you for asking that, Aliyah.
No problem.
Does anyone else have a question about what we've just shared you can offer? Can a second person offer a question about the material we just covered? And no, I'm not going to ask you to share your screen unless you want to. All right. What we'll do is move on, and I'm going to go ahead and share the screen then.
Actually,
Go
I
ahead.
guess it's not really a question. Well, it's more like clarification. Maybe I'm just not understanding this. Why is it that is it that the 255.255.255 has more holes than the 255.255.0.0? Maybe I'm just confused about that.
That's a great question. So to answer your question, I'm going to, and you'll see this again. So this is something we're going to revisit again, but it's good to see it more than once, and it's good to see it in more than one context. So I'm going to make my screen very big. And if you have 255, can everybody see my screen?
No.
Okay, let's share the
No.
screen. So here's 255.255.255.0. And this represents, and I'm going to put some spaces in here just because I want you to see what this is in real life. Okay? Because when we're using decimal notation, what it represents binary wise is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Is that, yeah? 1, 2, 3, 4, 5, 6, 7, 8. 0, 0, 0, 0, 0, 0, 0, 0. Now, people usually just, so that's 24 ones. Now, there's a shorthand way of expressing this. Instead of everybody saying 255.255.255.0, another way to talk about this subnet mask is to call it a /24 subnet mask, because there's 8 ones, 8 ones, and 8 ones, and if you add that up, it's 16 and then 24 ones in a row. Now, to clarify your question, Milrain, if I do this, right? Whoops. Oh, I want to put a 0 there, didn't I? What we really have is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Now, in binary terms, those zeros actually count. As human beings, we don't tend to write 8 zeros in a row. We're like, hey, 0 is 0. I'm just gonna put a 0 because that works. But in machine code, a specific 1 and a specific 0, a specific off and a specific on matter. Now, Milrain, which one has more openings for users? The first network or the second network?
I think the second one, right?
Absolutely. In fact, for every tick to the left, you double it, double it, double it, double it. So we have 255 potential network addresses in this kind of network. But in this kind of network, we don't have 255 or 256 addresses. We have 512, 1024, 2048. If I keep doubling, doubling, doubling 8 times, I end up with 65,536. So on this network, I can host 65,000 connected devices. On this network, 250, right? Huge difference. Because every time I add a 1, I'm decreasing or chopping the size of the number of users I can host in half, in half, in half, in half. And there's a doubling effect in the other way too. A half, a quarter, an eighth, a 16th, a 32nd, right? 1/256th of a Class B address, Class B network. That's a network that can host 65,000 networks. If I increase the subnet masks in different segments of that huge network, I can break it down into smaller networks or segment the networks. That's called network segmentation. I can create many smaller networks where I have better control and better security. When I have a huge open network, I don't have as much control and I don't have as much security. Why? Because instead of having 250 wildcards with a public radio signal where anybody can connect, there are 65,000 people that can hop on. And that's where your network security is really important. So there are aspects of our class here that we talk about that are profoundly important. A lot of times people just set up the normal, and what they can do is they can add some 1s to their home network until only 32 people can connect to their Wi-Fi. Why? Well, sometimes you might have a house party, but do you really want to set up your home network so 200 unknown people have the capacity to connect to your Wi-Fi, whether you're home or not? Ew. Just think about it. Over the weekend, I just want you to think about it. Would you want to just accept the default what your Wi-Fi router does so that anybody in a car near your house can get on your private internal network and get into your Kool-Aid? Ew. Just saying. And the stuff I'm talking about, right? These are simple things. So we're going to share with you what you can do on your Wi-Fi router to dramatically improve the security, where it's like Fort Knox. That's a great question. I'm glad you asked it, and it gave us a chance to explore some more. Did I answer your question though?
Oh yeah, definitely.
Okay.
Definitely.
So one of the things that you have to understand, we already know that the MAC address is like a fingerprint and it cannot be duplicated. The MAC address is a special identity assigned to the physical interface where it connects to the network. It has to have a separate identity. The network address allows that interface to operate between other connected. You have to have like a mailing address, okay? And so the subnet mask must be used to properly configure the device, and the use of a wrong mask can be bad. The intentional use, if you go in there and you change your own subnet mask, that can be bad. One quick example of this is when well, all right, I'm going to show you because I might as well get this over with. We're going to go into this a lot more, but where do I find this in here? Whoops. Sorry, just kidding. I'm back. I have a new system and I'm trying to figure out, there we go, where my stuff is. Network, Windows 11. There we go. I'm going to go into the properties. And I can go into edit the IP assignment in Windows 11. And really what I want to do is go into the device manager. So I'm going to move kind of quick here, but you can replay the video inside. Oh, no. On second thought, I'm going to go this route. I'm going to go to the control panel. And I'm going to go to my network. This is an older way of doing it. And I'm going to go, so this is the Wi-Fi that's connected. You notice it says public. There are different classes of network or classifications or types of network. Public network is considered the most vulnerable. So the network security on the firewall for this network connection tends, we'll talk about firewalls more in a bit. We're going to change the adapter settings. And now you can see I have an Ethernet port on my laptop. I don't have plugged in, but I have a Wi-Fi that's active. So I'm going to double click on this. And if I go into details, I can see the same thing that I just had on the screen in my command prompt, right? So I can put these side by side. It's just a different way of getting the same information. .4, all that. Everybody with me so far?
Yeah.
So I can go into properties, and here is something you should do as a practice. Everyone should uncheck and disable version 6, because there is no internet service provider in our entire territory that is currently operating with IPv6. And if that's active, there are some exposures for network security that we'll get into at a later time when we have a chance to learn some more, but just disable it for now. You're going to double click this one. You don't want to unselect it, but you want to double click it after you highlight it. And that will bring up this. So one thing you can do is you can take the information from here, and then you can manually assign it by clicking in here and then changing the subnet mask. So instead of having 255.255.255.0, you put more zeros in there. What that means is that you can see more of the clients connected on the bigger network. But you can only do that on a public network. That's something we'll explain later in our cybersecurity courses and later in this course. For now, what I want you to understand is that hackers know how to modify this value, the subnet mask, if they're on a big network like UVI's. If you noticed on the screen for Aaliyah, when she shared her screen, it showed preferred. She had a 24-bit subnet mask on the Wi-Fi network she was on. If someone intentionally changed the subnet mask, they could see all the devices connected on all of the networks, even other networks that UVI owns and operates right now. So what am I saying? Well, there's a wireless network where Aaliyah is connected to the campus. But elsewhere on the campus, there's a different wireless network. And in the athletic center, there is a different Wi-Fi network there. And in the bookstore, there is a Ethernet network. And they all use the 146.226 public network address range. So the ability to modify the subnet mask means you can start looking at stuff you're not supposed to, and that's not good. That's not good at all, because that can come back to haunt you. In any case, the important thing to understand about network addresses, and everybody sees how this is in big, right? This is big, big
Yeah.
print. Big print. When two devices on the same network at the same time have the same IP address, it melts down the address. Let me say that again. No two devices can ever have the same network address on the same local network at the same time. If they do, the network crashes. It becomes unstable and it dies. Everybody gets disconnected. It's a very bad thing, which is why we have to be very careful about how network addresses are assigned to people who connect. It's why there's a protocol to automatically manage that. Put another way, hackers can easily crash an entire network by just understanding the nature of a network. If they scan the network, find some addresses that are active, see that, oh, this one in particular, wow, that one's sending a lot of traffic. Well, now I'm going to send a lot of traffic, but I'm going to manually assign my connected interface to the same address. And then I'm going to push a lot of video data out to YouTube because I want to cap, or TikTok. I have a TikTok video. I'm going to push my TikTok video out on that address. That's going to flood the network. The network will get confused about which address, and it'll loop and it'll crash. Okay. Now, why doesn't that happen more often? Because there are logs. And what's going to happen is that a network administrator is going to find out that the person connected with this device at this location did something bad they weren't supposed to. And then you're going to go to jail, go directly to jail. You will not pass go or collect $200. I'm borrowing that statement from the board game known as Monopoly, in case any of you have ever played Monopoly before. Maybe not. Okay, so what is it you're going to do over the weekend? I need you over the weekend to pay attention to the assignments that are posted in Blackboard. So inside Blackboard, has everybody seen what's due?
Yes.
So in module 1, we have some things that are coming up that are due. And you can basically read the document and click and watch. And so it's pretty self-explanatory. And if you read the rest of the study guide, you'll have the information you need to actually complete the solution. I'd like you to try that. Over the weekend, I'd like you to read the rest of the study guide. Just read it. It's written in plain English, right? And if some of that is making you scratch your head, skip over the parts that aren't making sense right now. We'll review them again on Monday. Here's a further explanation about subnet masks, right? Where I explain this kind of stuff. So it's another way of reviewing the same information, and then the light bulbs click on, right? So if you look, you just have to start and read through there with a little bit of faith. And much of this is pictures and listings like this. So it's not as long as you think. It's not 10 more pages of fine print, but it's important information. Over the weekend, I want you to go ahead and review the rest of this, and then take a whack at your solution. We are going to use Monday as a workshop to walk through and assist with a solution where people are having, it's not working like it's supposed to, or there are frustrations, okay? So Monday is going to be really important. We're going to review the solution tasks step by step as needed. But I want you to try to see how much of this you can follow without my explicit action here, okay? Any questions before we close the class for the day? Okay, well, thank you for joining us. When we return on Monday, we will pick up where we've left off here in the study guide, just to check for comprehension. So that's another reason why it's really important that you take the time to read the rest of the study guide, right? And we'll explain the rest, and again, the solution, but get started on it, because if you don't get into it and get working with it, the class is going to mean a lot less if you don't get into it and get moving with it. So I'll stop sharing and stop recording.